Okay, very good. Now, Eliza did not show her work, but her answer is correct. Now, if you need to see the work, raise your hand.
Yeah.
Okay, let's put the work up here. So we have 261. And we know that 1 kilogram is equal to how many grams? 1,000. So we're just going to put in the denominator what goes in the denominator here? Yeah, 1,000 grams, because we want grams to cross out, remember? 1 kilograms. So this is a pattern that you're going to see next semester, and the reason why we're going over it now, because stoichiometry is basically using dimensional analysis in a balanced equation to solve for your desired unknown. So this is very important to understand. You need to get this in your brain that we're crossing out, and it'll prepare you for next semester, stoichiometry. Okay, Heather, once again, she gave us the answer, but she didn't show her work. Does anybody need to see the work?
Yeah, I'm gonna need to see the work.
Yeah, they're going to need to see the work.
Could you do 16 times 7 because there's 7 days in a week, then you do it times 24 because there's 24 hours in a day, and then you do it times 60 because there's 60 minutes in every hour, and then you do it times 60 again because there's 60 seconds in every minute.
Excellent. So this would be the math class method. Now the only problem with the math class method would be if you go out into the real world, right, and you start doing an inventory. You have to write down things in units that you're working with. This is causing a lot of people trouble. They're like, that's work. I was never taught to do that work. It's easier just doing it, doing it like this. However, if you're a manager, they will pay you more money. So just knowing that you have to write a unit next to your number really will benefit you as far as you will move up in the pay scale a lot faster if you understand math. Now, I say that because if you go to school and you pass the test and then you get your degrees and you go and you work somewhere and you decide not to write down your units right here, they're going to want to get rid of you. Now, the department stores are stressing out a lot right now. My mom, she works at Steinmart, and she says, sales are down because people are doing a lot of online shopping.
That's what
Yeah.
my mom does.
Yeah, online shopping, big thing. Yeah, you can get a lot of really good deals. I prefer it quite often. You can find what you're looking for probably 30% less online. And it's true, like if you have a certain brand, like over here, Heather has these Uggs. So does Eliza. Oh, do you all both have the same Uggs?
Yeah.
Yeah, so the Uggs, those are expensive, right? And it's a brand. Oh, do y'all get the same Uggs? Y'all are like Ugg friends. Everybody likes those Uggs? Yeah. You put it on your wish list. You go to Santa and say, Santa, you give me some Uggs. What?
No. I'm asking for Chacos.
Oh, those are nice.
I do not. I love Chacos.
Chacos.
And I really, really, really want the Vans, the high top Vans that have like a little check mark. I like those. Oh my gosh. I made mine. It has websites and the size and the color. I know. You stop drawing on my paper.
1 hour, 60 minutes.
I told my grandma that I wanted indoor ring. I told her the exact size and the exact time. And she got me the whole thing. It was correct, except for the long stud.
All right, so Claire, you'll see up here that the weeks cross out, days cross out, hours cross out, minutes cross out, and you're left with second. So this is called, they call it the train method of dimensional analysis. You have one conversion after the next to get to the final product. Now, dimensional analysis like this is not easy. Now, this one is fairly easy because most people know weeks, seconds, hours. They know those units to figure out. But oftentimes you will not know when you have a complex conversion from, let's say, grams to something smaller or something larger. all of the units in between. That can get a little bit difficult. You have to do a little research in the textbook to find out which conversion factors you need. So just keep in mind the most important thing.
Sorry. Are you going to give us the conversion too?
Yes, I will give you the conversion factors on the test.
Got it, done. Oh, no, this is real wood.
I don't know if this one's right.
Skirt.
So 1 hour is 3,600 what?
I don't know. I think it's supposed to be.
That's seconds?
Yeah.
That might be the conversion factor only.
Yeah. I think it's
Okay, nice job here. Now, this dimensional analysis is probably one of the most used methods for determining the amounts you need if you have a, let's say, a restaurant. Because you have to figure out, okay, how much do I need to order if I have 15 people coming, or 30 people coming, or 100 people coming. Is that right? All right, now if you need to see the work, raise your hand for this problem. Can you see the work? Can you show how you got it? Okay, Zane is correct. He's showing the correct math. This is how you would show it if you're going to put the units on your numbers. You see, Zane doesn't have any units except for the last one here, but you should always number you should always put a unit on what number you have. Like you see right here, 1 year, 365 days, 1 day, 24 hours. So you'll see the years cross out, days cross out, hours cross out, and you have minutes in your answer. Now this is going to lead you into next semester when we get into stoichiometry, which concerns dimensional analysis and balanced equations. Gillian did a nice job solving for the next problem, or correction, the first one, where you have 9,474 millimeters, and you're converting that to centimeters. Here's how you're going to do that with the conversion factor. 1 centimeter equals 10 millimeters. Solving for centimeters. You see how the millimeters cross out? Nice job, Gillian. Good. Nice try, Rain. The problem here is that you didn't set it up properly. You're not seeing how the inches cross out, feet cross out. Then you can put this in the calculator and then solve for 0.085 miles. PT came up with 8.400 centimeters, converting 840 inches to centimeters. Okay, so the answer is 2,133.6 centimeters. Close, TT. So you might want to try number 2. So Michaela gave us our first attempt on this problem. What I like to do is separate the units on like this railroad track. Now next semester when we're doing stoichiometry, which concerns using dimensional analysis in a balanced equation to solve for an unknown like a product or a reactant, this will pay off for you if you're understanding how to do this. Once again, the simple pattern is to draw your line just like it says per here. So the milliliters are in the denominator, grams in the numerator, and I set it up to where my grams are going to cross out. 1,000 grams, 1 kilogram, 1 liter, 1,000 milliliters, the milliliters cross out. Then I get my answer, equals. Anybody got to calculate that for us? Put it up here, points.
Would it be there? No. Oh. Is this one right?
Now look, if you have 1,000 here, right, and 1,000 here, will those cross out? What's 1,000 divided by 1,000?
1.
All right. So what's 1 times this?
Oh. 0.41.
Yes.
So it's just 8.41?
Grams per kiloliter. Don't forget the units, because remember we're converting these units. It would be kilograms per liter. That is.
So should it just be that?
Kilograms per liter. Excellent. No, we got married over at Fern Creek, Christian. She grew up over on Lovers Lane. No? Why would I do that? Once again, this is the railroad method. We're just continuing on with, we do a line right here, and a line, it would be vertical. Yeah, perpendicular. No, that's horizontal. This is vertical, obviously. And then we put our 365 here, 1 year. We're just going to continue on over here. So,
60 minutes, 1 day, 1 hour.
very good.
We did this in algebra last year, and I hated it.
Yeah, but it's used quite a bit. Especially if you're going to like open your own restaurant or open your own business, you have to figure out conversions between what is sold and what is like on sale and things like that. Also, like hot dogs don't come in the same package number as like the buns do, so that's when this really comes into play if you're going to order for a lot of people. So where's the unit for this one? You're right. You got the right one because it says to seconds, so you're on the right with S. It says 2.3 days, 2 seconds. So it should just be seconds, right? Oh, okay, 3 days. That's the number then. All right.
So it'd be 3D.
No, it's just going to be 4,200 seconds. Would be equal to 3 days, but you're just going to say 4,200 seconds. And then up here you underline that this is the answer for, so it's going to be, you're converting this to kilograms, right? So that's 261 grams is equal to how many kilograms? It can't be the same.
1,000?
Well, let's write this out.
But I thought you said there were 1,000 kilograms.
The grams will cross out here, right? You're going to get 0.261 kilograms.
Okay.
So follow the unit.
I threw away the paper with all this showing the words.
So let's take the track method. We're going to place the kilometers in the numerator and the seconds in the denominator. So the railroad track method. So now I want to convert to miles, right? So I'm going to have to find something that's going to allow me to go from kilometers to miles on my conversion chart right here. So I've got a conversion chart. I'm going to pick something. Continuing on with our railroad track, we got kilometer. 1 kilometer is 1,000 meters. We can get 1 mile is 1,609 meters. Now, if you run track, they typically run a 1,600 and a 3,200, and they often say that's the mile, but it's really not. 1,609 is actually a mile, so your time on the 1,600 will probably be, lower than an actual mile, because 9 meters will make a difference. Yeah, 9 meters could make 3 or 4 seconds difference. Probably more like, 4 or 5 seconds. Depends how fast you are. Now let's convert, continuing with trying to go to a year, right? We have seconds. So we have 60 seconds is 1 minute, right? Then we have 60 minutes is 1 hour. And then we have 24 hours is 1 day. And we're trying to go to what? Years? And 365 days is equal to 1 year. Now, this is a long conversion factor, a long dimensional analysis. You're going to see one similar to this next year, which is why we're going over this now when we look at stoichiometry. Stoichiometry concerns using this and balanced equations. So we get our conversion factors from a balanced equation. For an example, balanced equation might be like this. You have hydrogen plus oxygen makes what? What's hydrogen plus oxygen make? Raise your hand. Andrew? Water. H2O. Now, Francesca, you'll see Zadie. 3 times 10 to the 7, whereas we calculated to be 7.45 times 10 to the 7. Probably because of this here. She probably made an error on this conversion factor. So let's check what you got here. We started off with kilograms, and we're going to
Stay in kilograms.
go to milliliters. Okay, that's a fairly easy one then. You're just crossing out the liters to milliliters. Okay, looks good. Good job. So Annette's doing a really nice job with the railroad track method. So who's gonna get it right, Jacob or Annette?
Come on, Jacob. Go, go, go.
They're solving the same problem. We're gonna see who's correct. Looks like you both got the correct answer, so most likely it is correct.
Doing a good job, isn't she?
Got the low battery warning.
5%.
Still good. 0.81. That would be pound per gallon. Method. You're going to want to put one of the units that's per. You see how you got a line there? It's divided. That means per. That would be meters per second. So here's your numerator, and then per seconds. So we set it up to where we have the seconds in the denominator. So now we can just fill in the blocks. This works really well for people who kind of want to place things where they don't move around. So the meters, 1609, 1 mile, and then 1 hour is 60 seconds. Anybody solve for this? I got the answer?
I swear to God.
So you can see how the meters are going to cross out, and you're left with mile. Right. So you're going to draw a line. Here. Now you see the second here? The second here? Where are you going to put that to cross out? Yeah. And then you got to put... So we had a correction on the last one. This really goes from seconds to minutes, minutes to hours. It's 55.93. Okay, so Ben asked a good question. He was like, what's the railroad method? This is your traditional method where you have your division multiplied. The railroad method just simplifies all that to where you get your desired answer. So here we converted from meters to centimeters, and then from centimeters to inches, inches to feet. You can do it both ways. Whichever way is best for you, Ben.